In 2015, we won the Regional Science Bowl, Miller, and in 2016, Miller won the National Science Bowl. In 2017, they also won the National Science Bowl. In 2018, they didn't really get into nationals, so but we won regional second place.
This is going to look got second as well. And third.
What are you doing?
So that was the end.
What's the celebration?
There is no celebration.
What does that mean?
Okay, so the Science Bowl is like Quiz Bowl, or like you've heard of Quiz Bowl. It's a fast-paced buzzer competition, and it's Jeopardy style. And there are 25 questions in each round. And these questions are either toss-up questions or bonus questions, which are rewarded to the team that gets the toss-up correct. And toss-up is 4 points for a correct answer, 0 points for incorrect, and subtract 4 points for incorrect if interrupts.
Yeah.
Flirting, which is basically like when you buzz, and then like before, basically when you buzz, the person has to the judge has to recognize you. It's like say the name, like for example, A4 or something. And if you say the answer before they say that, then it's called flirting, and then you get a penalty for that. And you just send like 4 points to the other team.
Science Bowl covers.
We're genetic.
That's under biology, so that's technically life science. Physical science is physics and chemistry. Or space energy, and yes, math. Now, math is actually the hardest subject because everyone has that one guy who can do really good math. What I'm just talking about microvision. So, first of all, for plants, the main thing you need to know, the diagram on the next page, is about xylem, phloem, and flowers. How many of you have heard of flowers? No. Good, okay. Xylem and phloem, how many of you have heard about those two? Oh wow, smarter than I was. Okay.
And there are two types of quantities. Scalar quantities and vector quantities, and we have heard of these. And scalar quantities are just like one number, like a magnitude, and vector quantities have a magnitude and direction. So an example of a scalar quantity would be like speed, distance, time, or mass, because it's just a number. And a vector quantity would be like velocity, because you can say we're going like 20 kilometers per hour east, so we have the magnitude 20 kilometers per hour, and the east, which is the direction. So that would be a vector quantity. Yes?
I still don't get what scalars and vectors are.
So a scalar quantity has just like one part of it, which is the magnitude. For example, like mass is just a number, right? And then vector quantities would be like velocity. Velocity would be like 20 kilometers per hour, which is the magnitude, and the direction, which is east.
Yeah, so compare like 5 miles an hour and 5 miles an hour east. So the thing about vectors is they have direction.
So you've probably heard of this already, so I'm just going to briefly go over it. They're just Newton's 3 laws of motion, and they're the basis of kinematics. And the first one is called the law of inertia, which is that an object's velocity will not change unless an unbalanced force acts upon it. So like a rock will just stay on the ground and not move unless like I push it or something. And the reason why the rock will eventually stop if I push it is that there's an unbalanced force, which is friction, that will stop it. And the second law of motion is force is equal to mass times acceleration. There's F equals ma. It's just the force of something is equal to the mass of the object times the acceleration. And the third law is that every action is an equal and opposite reaction, meaning that if I like push an object, then the object will exert the equal amount of force that I gave it back into me. So next we'll be talking about work, power, and energy. So work is defined as force times distance, and it's measured in Newton meters, which are also joules. And there's also power, which is the amount of work something can do per unit time. So for example, Newton meters per second or joules per second. And then there's energy. There's two main types of energy, potential energy and kinetic energy. And potential energy is known as stored energy. And one specific type of potential energy is gravitational potential energy. So it's like how much stored energy if you like hold an object. It has a bunch of stored energy because if you drop it, then that energy will turn into kinetic energy, which is energy of motion. And gravitational potential energy is equal to mgh, or mass times acceleration of gravity, which is g. It's just a constant, which is around 9.8 meters per second squared. And then multiplied by the height of the object. Then kinetic energy, abbreviated as KE, is equal to 1/2 times the mass of the object times velocity squared.
So here's a common science book question, see if you can figure it out. It has a little trick to it. So it looks like this. Tommy is a very strong man, and he wants to lift up his couch. He exerts 500 newtons of force to lift the couch, but it simply does not budge. How much work has Tommy exerted? Or has Tommy done? Yes?
No work has the couch is
Yeah.
Yes.
Yeah.
So he gave 500 newtons of force, but it didn't
There's no
move.
distance.
So he did no work. So remember that work is force times distance. If they ever say something like, but the couch didn't move, the answer is 0, because they're going to ask you how much work they did.
Oh, it's a cup.
Yes. Okay. You get 3 candy.
Do I get
That's
the
the answer.
I
If you guys answer questions, you're going to
candy?
Oh,
Any
okay.
questions?
Okay, I can move on.
want the chocolate candy.
Okay. So another part of physics and lots of scientific physics questions also test on current electricity, which describes electrical circuits, and mainly there are 3 components: current, voltage, and resistance. And current is the amount of flow of electricity in the circuit, and voltage is like the electrical potential, or like how much something can flow from one place to another. And resistance is how much a wire opposes a current. And there's one law called Ohm's law, which describes the relationship between voltage, current, and resistance. And it's that V equals to IR, or voltage is equal to current, which is I, divided by resistance. And there's another law which doesn't really have a name, but it's informally called the power law. And it's just that power is equal to current times voltage, but do not confuse this with
It's
the
not
power
this.
we talked about in this one. It's electrical power, which is slightly
So these are 2 different powers, yes.
So what was I in Ohm's law?
current.
So as you study science, you'll notice that a lot of variables are named very weirdly sometimes, like they're not just the first letter of the variable or the unit. This is either because there's something cooler that was discovered first that already has started with that letter, or because it's usually from German or French. And so the Germans and the French call it something else, and that's what the first letter is.
Okay, so finally, I'll be talking about optics, and optics questions are sometimes tested on in science schools. And one important formula you really need to know is that speed is equal to wavelength times frequency, which you might have remembered from the optics lesson on Tuesday. And this is basically like the speed of light is a constant, which is always 3 times 10 to the 8th meter per second, because the speed of light is always the speed of light. And this equation can be useful if they give you like the wavelength, then you'll be able to find the frequency of this light, because in order to find the frequency, you just do speed divided by wavelength. And there's one thing called diffraction in optics. Diffraction is basically this phenomenon that light will bend as it goes around corners or edges, and when it goes through tiny slits, it'll like disperse and go spread out. And the final thing is interference. There are 2 types of interference: constructive and destructive. Basically, what interference is when 2 light waves come toward each other. They both have like amplitudes, right, which are like heights. Constructive interference is when they come towards each other, and then their amplitudes like sum up. And then destructive interference is when they like cancel out each other, and the amplitude gets less.
So constructive interference is like addition. You have 2 of them, and you add up the amplitudes, and it gets like bigger. Destructive interference is like more like subtraction. So even though it's called interference, it's not always like the interference we normally think of. Any questions?
Any questions for physics?
Okay, then we'll move on to chemistry.
So, as you probably know, chemistry is all about atoms, molecules, and compounds. And atoms, everything is made out of atoms. And atoms consist of a nucleus made out of neutrons and protons. and an electron cloud all around the nucleus. And neutrons have no charge, protons have a positive 1 charge, and electrons have a negative 1 charge. Molecules are when you have 2 or more atoms bonded together, and compounds are when you have 2 or more atoms of different elements bonded together. And elements are basically like a type of atom, and molecules can be 2 of the same type of atom bonded together, like O2, oxygen. And here's a diagram of a carbon atom. So the carbon atom, it has an atomic number of 6, which is, the atomic number is the number of protons, and it's what defines an element. So if you change the number of protons, then you change what element something is. And this carbon atom has 6 protons and 6 neutrons in its nucleus, and it's surrounded by 6 electrons.
So normally the most stable elements will just be like every number is the same, 6 protons, 6 neutrons, 6 electrons. But there's one atom that has 0 neutrons in its most stable state. Does anyone know which one that is?
Hydrogen.
Yes. And the easy way to remember that is just, if anyone feels like the answer, raise your hand. I have Starburst for you guys. Okay. Oh, no. Okay.
Can I keep it? Can I keep it?
That was chaotic. You can keep it.
Yes!
Okay. So.
This is all the periodic table of elements, and it's just a way of organizing the elements. So I'll just briefly go over the periodic table of elements. So the rows of the periodic table are called they're called periods, and then the columns are called groups. So in the far left, in group 1, we have not including hydrogen. We have the alkali metals, which are very reactive metals, and then in group 2 we have alkaline earth metals, which are slightly less reactive. And then to the right of that, we have this big chunk, which is like transition metals. And transition metals are like your everyday metals, the metals that you think of, like copper, iron, and gold. And over here, this light green color, these are non-metals, which are pretty different from metals. They have like very different properties. And there's like an in-between, which are called metalloids, and they're just like this blue-green color over here. And to the far right, we have, in group 18, we have these noble gases, which are just gases that don't react in there. Okay, so there are 2 types of bonds in chemistry. One type is a covalent bond and one is an ionic bond. Covalent bonds are formed by sharing electrons, and an example of that is H2O or water. And an example of an ionic bond is table salt. And ionic bonds are just formed when atoms become ions, which is basically like in NaCl or sodium chloride table salt, that sodium will give, it will give 1 electron to the chloride, so then they both become ions. Then table salt is formed.
So the general rule of thumb you can use is if the bonding is between the far edges, so one on the left and one on the right over there, excluding the noble gases, that's ionic. Yeah. So like table salt. Anything that happens in the middle is usually covalent. Yes?
So someone mentioned something about like that thing written in the middle is like half-life, like that's like the decay rate or something like that? Or?
Yeah, so the half-life is how long it takes for half of the substance to decay into another substance.
Why isn't it known as like life or something like that?
Because
It's kind of like probability.
or it's like exponential decay. We know that it'll keep halving over and over again, but it'll never reach 0. It just keeps going half, 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 half. So half of 1 is 1/2, half of that is 1/4. It'll never reach like 0. It'll just keep getting smaller and smaller and smaller. So the full life is infinity, but we can measure the half-life. Yes.
If an element is below another element, then those 2 are similar, right?
Yes, similar properties.
Do they react with each other necessarily?
Possibly, but it's more unlikely than reacting with. These guys are like reacting on the very right here, and on the very left here. These guys love reactions. If we had more time, we'd show you a video. You can search it up at home. It's called Alkaline Metals and Water. You can watch them exploding and catching on fire. So, if you want to search that up later. Last question here?
For metals, and non-metals, why does metals have to be like, why can't metals be like the same color and non-metals become like a different color?
The colors are arbitrary. It's just like as a distinction. In real life, it's not all metals are brown and all oxygens are blue. These are just random colors for readability. Yes. Yes, there are metallic bonds too, but we're probably not going to talk about that right now in time because of time.
Some question we can ask later.
Yeah. If after class you want to stay behind and ask something, we can ask it.
Okay, so there's one property of aqueous solutions, or some liquids, called pH, and pH is just a way of measuring acidity or basicity, and basicity is also known as alkalinity. And there's a scale, the pH scale, which ranges from 0 to 14, and the middle is 7, which is water. And here is just 5 normal, like everyday positive ions. And you can see where they go on the pH table just for reference. So battery acid has a very low pH, so it's very acidic, and train cleaner has a very high pH, so it's very
And your blood is slightly basic. Okay, we'll take one question for each slide at most. Yes? Okay. Yes.
Why do batteries classify as acidic?
So we measure acidity and alkalinity by looking at the hydrogen ion concentration in the water. So it's just that way. Yes. Yes.
Most things have the pH 1. Would it be able to burn your skin?
Yes.
So finally something that's sensitive. Yeah.
Borax, people say that borax gives you like a 3-degree something burn on your hand.
I'm not too sure about that. Sorry.
Okay, so finally, there are moles, which are basically just amount of substance or amount of like stuff. And a mole is defined as the number of atoms in 12 grams of carbon-12. And what carbon-12 basically is, there are 6 protons and 6 neutrons.
So that's the regular carbon we're thinking about. You guys might have heard about carbon-14. That's what we use for radioactive dating. This is not dating like getting a boyfriend, girlfriend. This is the dating like we talked about the half-lives. It's how we figure out how old something is. There's a half-life of about 5,300 years. 5,370. That's the half-life.
What's uranium's half-life?
Same type of mineral. There's also a hardness fracture, which is how the rock or the mineral breaks. Crystalliform cleavage and luster. And usually they'll end with something light. So minerals make up rocks, and as someone mentioned, there are 3 types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks are what we say like they're born from fire. They're made from the cooling down of lava. If you want to know, magma is beneath the earth. Lava is when it comes to the surface, but they're the same thing, just different names based on where they are. Sedimentary rocks are like sort of like squished together through time. That's like sandstone, limestone. Those are sedimentary rocks. Metamorphic rocks are when they go underneath the Earth's surface, and there's a lot of heat, and there's a lot of pressure, and they change into things like marble, right? And you a hole in the ozone layer, we usually hear about chlorofluorocarbons, CFCs. So those came from refrigerators. They go up into the atmosphere and they destroy ozone. Petroleum and coal, we normally worry about the greenhouse effect and global warming. Okay, non-renewable energy. The answer when if they say coal, the answer is anthracite. This is a 100% promise. Try at any science board tournament, even if it's official. You don't even need to listen to the question. They say what kind of coal, the answer is anthracite. Okay, anthracite is the highest grade of coal. This is the favorite type of coal of everyone, okay? This has the highest carbon grade. So in order of progression, we start with star, but we do need division. Questions? Yes?
Why energy produces geothermal energy too?
So math is a really part of science, but it's like fundamental basis of science. And math and science will usually like based on speed and accuracy, so like they're usually pretty easy, but you want to try to get it before the other teams. So usually you have to like get it within like 2 seconds or something like that. And most math problems are algebra based, and some are word problems, and sometimes there's basic logarithms in trigonometry. And I'll be teaching a little bit of logarithms in trigonometry. And one strategy is to find shortcuts because you want to do that, right?
So math is known about speed because there's almost always someone who can do math on both teams. So this is who can do it faster. Some question. Raise your hand when you get it.
Plus y.
Said you don't count.
Now we
Apparently, apparently I don't count as a person, Michael.
19 minus
Yeah,
1.
that's correct. Okay.
Yeah, but
Okay, so
you have to
And then y times 19.
Let's finish up.
yeah, this is probably a thousand questions, so you probably only get 5 seconds. So the first thing that comes to mind for me is to like set up a system of equations like a plus b is equal to 19, and then a times b is equal to 48. Like that would be a little bit too slow because you have to like substitute like a or b back into like a times b equals 48. Now that'll take forever. So what you can do is you can like kind of test the factors of 48. So your answer would be
common mistake in math is
another part of math questions is logarithms. So basically the definition of logarithms is that log of base a of b is equal to c, then a to the power of c is equal to b. So I can kind of like explain it like log base 5 of 25. Since 5 squared is equal to 25, then log base 5 of 25 is equal to 2. So it's kind of like the inverse of exponents.
It's okay if you don't get this right now. We'll probably go over this.
Log and then log 5. Oh no. 24.
Okay, so we have this equation, right? It's find the value of x if log base 2 of 64 is equal to 3x. So first what we want to do is we want to solve we want to solve the left side of the equation. Log base 2 of 64. So you're asking yourself like 2 to the something is equal to 64. So you want to find that something. And that something is just 2 to 64. And you just divide both sides by 3 to get the x is equal to 2.
I already did it 5 years.
Yeah, I question that because
I already solved all of them already.
Okay, guys, we're nearing.